Do page 729. Are you?
Go ahead. Go ahead,
Page
Professor.
729, example 4. This problem is worked out in the book, but I want to work it out in great detail. It says as follows. Suppose that the production capacity for a certain commodity cannot exceed 30. That means you never make more than 30, whatever the item is. The total profit of this commodity is given by the formula P of x equals 4x cubed minus 210 x squared plus 3600x minus $200, where x is the number of units sold. If this is the profit formula, x is the number of units sold, the profit's in dollars. Then find the number of items that will maximize the profit. So this is a maximum problem. If I ask for a relative maximum, we simply take the derivative and set it equal to 0, and we have to find, is it a maximum or a minimum? This problem is more complicated because it says it wants the maximum. Just to draw a graph, if I take the derivative and set it equal to 0, I don't know if I'm here or here, so I have to check, is it relative max or relative minimum? However, the graph looks like this. This point might be higher than this one, so this is an absolute max. This is a relative maximum, this is an absolute maximum, meaning it's the biggest thing in my graph. If they want to maximize profits, they want an absolute maximum. Sometimes the graph looks like this. So the relative maximum is the biggest thing, it is the absolute. Sometimes it looks like this, and therefore the end point is the maximum. So we have to determine, is the relative maximum the maximum, or is the end point the maximum? So we have to consider both possibilities. So first we have to take the derivative. P prime of x equals 12x squared minus 420x plus 3,600. We want to set it equal to 0.
So the derivative of the first problem, so the original P,
That's the derivative.
very simply.
And we emphasize, we're working in the interval, 0 is less than x is less than or equal to 30. Now, if I put in 0, obviously that'll be a low number. If x is 0, that's not going to maximize profit. Something's wrong if you make nothing, you have maximal profit. But possibly x equals 30 will be a maximum because this is the end point. First you have to solve this equation. To solve this equation, we factor it, and we get as follows. It's 12. This is x squared plus 12 into 420, just a minute. 12 into 420, don't remember. There's 3, 36, it's 35, minus 35x plus 300 equals 0. I continue to factor this. This is 12, this x. This becomes x minus 15 times x minus 20. 15 and 20, negative 15, negative 20, multiply to be plus 300, and they add to be negative 35. So this equals 0. This means x minus 15 equals 0, or x minus 20 equals 0. So x equals 15, or x equals 20. Generally, you cannot have two maxims in a row. If you have a graph, you either have a maximum followed by a min, possibly another max, or a minimum followed by a max, possibly another min. So one of these should be a min, one should be a max. The question is which is which. So we have to see which is the minimum, which is the maximum. So the way we're going to look at this is we're going to look at the first derivative. If the first derivative is less than 15, this is a negative number, and this is a negative number. So if x is less than 15, first derivative is positive. They're going to say it was positive. When x is 15, it's 0. And if x is between 15 and 20, this is positive, this is negative, so the product is then negative. So 15 is less than x is less than 20. This is the first derivative. It's going to be positive 0, negative. That is the sign of what? That is the sign of a maximum. Positive, 0, negative. Positive derivative, 0, negative. Then once it reaches 20, x equals 20, it's 0 again. And once x is greater than 20, then this is positive, and this is positive, becomes positive. Here x equals 20, it's positive. So negative 0, positive implies we now have a minimum. So first, therefore, this must be a relative max. At 15 is a relative max, and at 20 is a relative minimum.
Real briefly, could you just go again how you took those numbers? I understand it, but
15 and 20 are critical numbers.
Mm-hmm.
So if we're to the left of 15, this much here, I suppose we're at 13 or 10, this number is negative, this number is negative. I multiply them, I get a positive number. That means my first derivative is positive if x is less than 15. When x is 15, the first derivative is 0. If x between 15 and 20, this is positive and this is negative. And the product is negative. Therefore, if x between 15 and 20, the first derivative is negative. If x equals 20, the derivative is 0. If x is greater than 20, both of these are positive. The product is positive. So positive 0, negative is the sign of a maximum. Negative 0, positive sign of a minimum. That means x equals 15 is a relative max, and this is a relative min. So our guess for the best value of maximum profit is x is 15. But x is 15 in here. Why don't I compute p of 15 equals 4 times 15 cubed minus 210 times 15 squared plus 3600 times 15 minus 200. We will compute that in a minute. This will be the relative maximum. The question is this the absolute maximum? If we're between 0, we have to come in. There's another class going to come in here, so we have to stop in 1 minute. We also have to compute the end point. 0 is not a point worth considering because you don't want to make 0. So we can say other point 30, because here it's going to go up 30. We compute p of 30. This equals 4 times 30 cubed minus 210 times 30 squared plus 3600 times 30 minus 200. If you compute each of these, we have to see p of 30. This is the maximum. This equals 26,800. This is the bigger number. This one is the bigger number if you try computing it. So therefore, this is the ideal production, 30 units. We have to stop here. Thank you.
all right.